Alright, hello everyone and welcome back to my tutorials. Today we will be going through the Gyro straight program. This is basically going to be a program where instead of using straight blocks like this, we will create our own program to create a more precise and accurate program so that it can go straight even if there's a little bit of drift. So a popular problem with the EV3 and any robotics actually is that there can be a little bit of angular drift, which means you tell the robot to move completely straight. However, some little disturbances and things like that can cause it to go off course when have a little bit of a turn or anything like that. So we're going to be making a program today to solve that problem. This program is basically going to use the gyro sensor to detect any sort of drift, and it will automatically correct for that drift, and hopefully create a much more stable and accurate program. So the first block we have to use is, of course, the gyro sensor. So we have to use the gyro sensor and reset it. So if I can go over to here, gyro sensor, and then hit reset. So this will basically set whatever the gyro sensor is reading to 0. So the gyro sensor starts reading values as soon as you turn on the program. So when you do this, it will start reading it from the beginning of the gyro straight program. You need this because if you've already turned before, then it's going to have to do math over there, and that it will disturb what your program will do here. So once your gyro is set to reset, now we have a 0 reading from the gyro sensor. Next, we want to start a loop. We use the loop because we want it to check for the angle continuously and not just once. Because if we just check once, then after the loop is done, it could drift again, and then it basically renders it useless. So we want to put this into a loop and check continuously for any sort of angular disparity. And this is exactly what the loop is for. Right now we can just set it to unlimited, but we will change that later. So next, we can read the gyro sensor value inside of the loop. So we want to read this value. As it changes, this value will either go up or down. It can go to the negatives. So basically, if it turns to the right, it will be a positive number. And if it turns to the left, it will be a negative number, assuming that you have the gyro sensor facing forward. If it's facing backwards, then it will be the opposite, of course. So if it's right and it's facing backwards, then it will be a negative number. And if it's left and it's facing backwards, it will be a positive number. So now we want to get some math. We want to multiply this value by -1. So why are we multiplying it by -1? If we pull this into here first. So why are we multiplying it by -1? So if the robot turns to the right, you will get a positive value, assuming that your gyro sensor is facing forward. So now what do we want it to do? We want the robot to turn left. We want it, and we know that the left motion is negative in the steering. If you go into a steering block, left is a negative number, as you can see here. So if I want to turn left, I have to get a negative number, and if I want to turn right, it's a positive number. So basically, we're trying to negate whatever angle this is reading. So if it's reading a positive value, that means it's turning to the right. We want to do the opposite and turn it to the left. So this -1 basically turns whatever angle is going on here and turns it into a negative, so that we can actually plug this into the direction. So now if it turns right, say 10 degrees, then it will go through this math and turn it to -10 degrees, or just -10, no degrees. It'll turn to -10, and then it will go into here, and this will turn the robot to the left. And if we set this to on, this will happen forever, regardless of rotations. And this program by itself will work. You can try this right now, and it will work. However, it's not really useful, because this is just going to go for infinity. It will continuously do this forever. And when you're trying to use it in a program, it's not really useful because you want it to go a certain distance. So that's where we can do some math again. So there's another sensor, as we talked about earlier, called motor rotation. This can measure the motor rotation of both of your move steering motors. So in my case, it's ports B and C. So if I type in port B and then port C here, we can do some math to find the average rotation. So these guys are not, they won't be exactly the same, because say it turns to the right a little bit, then the right wheel will have a lower rotation than the left wheel, because that's how the robot turns. Since this is in a car and we can't actually just turn the wheels like you can in a car, the way it turns is by slowing down one of the rotors so it pivots on that rotor. So for now, we want to figure out the average between these two. So for that, we got to bring up some math. And we can go into the advanced so that we can get this, we can type it into here. So to find out averages, you do A plus B and then divide it by 2. Or we could type in C here. So, sorry, not A equals B. A plus B. A plus B. There it is. A plus B divided by C. So if we plug one of these in for A and then one of these for B, and then we want to divide it by 2 because that's how many motors we have. If you have more motors, you can divide by 3 and then so on and so forth. However many terms you have. All right, and now we have the average rotations between these two motors. So we want to say once it reaches a certain level of rotations, wait, first of all, we want to change this from degrees to rotations, because rotations are much easier to work with than degrees, as we will see in a second here. Sorry about that. There we go. Now it's in rotations, and it will count the rotations, and it will give us the average rotations between them. All right, so now we want to pull out a compare block. And we will use this for equal to, or I prefer greater than or equal to here. So first of all, we can plug this into A and then set a certain number of rotations that we want the motors to go for. This will depend on the circumference of your wheels, the circumference of your wheels. As the higher the circumference, the more it will go in a single rotation. The reason we're using greater than or equal to here instead of just equal to is because sometimes the program can skip over the exact equals to of a certain value. So say I type in 10 here, so I want it to go for 10 rotations. If one of the readings is 9.9 and then the next one is 10.1, then it technically never hit 10 and it will never end the loop. So it's a lot safer to go into greater than or equal to, so that even when it hits 10.1, the robot still knows that it's time to stop. And we can use this as an end condition by changing this unlimited to logic and then checking for true, and then we can just plug this into here, and there it is. So now after this program is actually useful now. So after 10 rotations, we will leave the loop, and we can go on to the next part of our program. I will now demonstrate how this program works by playing it on my robot and periodically lifting it up and changing its direction. After that, I will set it down and watch what it does. So as you can see, when I set it back down, the robot does its best to return to its original heading. So even though this program works, it can become a hassle to try to estimate the rotations every time. So to fix this, we can actually convert rotations into inches of travel. So say I know I have to travel 10 inches, but I don't know how many rotations that is. We can do some math to find that number here. So we can put this outside of the loop because we don't need to check this every time. And we want to make the loop as short as possible so that it's faster to go through it. So first we have to change this to divide. And then we have to figure out the circumference of your wheel. In my case, the circumference is 6.5. So for B, I will change that to 6.5. And this is in inches, by the way. So 6.5 inches right here. And then A is the amount of inches that I want to travel. So if I say I want to travel 2 inches, then it will take, or if I want to travel 6.5 inches and my circumference is 6.5, then 6.5 divided by 6.5 is 1. And this will give us the number of rotations. We want to just go one rotation because that one rotation is equal to our circumference. And then we can plug this into our logic right here. So it will check to see when the average is greater than or equal to this number of rotations. This way, we just need to type in the number of inches. So if I want to go 10 inches, then it will go 10 inches and it will automatically do the math for the rotations for me. And I won't have to do that every time. This is super useful. And that is basically the end of our program here. This is the most compact way of doing this in the simplest form. This is going to be a great program, and it will make sure that the robot will not drift as much as possible. And it's very useful to have a very consistent and accurate programming in your in your FLL tasks. However, there is one problem. If you want to use this in your program, this is a lot of blocks. This is a lot of steps that you need to do every single time you want to go straight. So to fix this, we can actually turn this entire thing into one block. If you highlight your program just like this, and then go up to Tools, and click My Block Builder. This will allow you to turn this entire program into one single block. And this is really where the magic begins. So we want to add two parameters here. One for speed, so we can choose how fast we want the robot to go. And then one for distance. We can choose how the distance that we want it to travel. We can name this into Gyro underscore Gyro straight, just like that. So now if we ever need to find it again, it will be under the name Gyro straight. And we can change the icon. So because we're driving, I'm going to use this icon, and it will have the two wheels just like that. And then for parameter setup, we can go into A, and then we can name this speed, and it will be an input. We will go over that later. Make sure it's on input. The data type will be a number, and we can use this this type of parameter style. And the min will be -100 and the +100, just like a normal move block. And then we can change this parameter icon to match the speed. So if we go over here, I like this one. So now it will show up as a speed icon so that if anyone's looking at it, they will understand what it means. And then next we have this one. This is the distance setup. Distance. And this is also an input, also a number. However, we're not going to use this because we don't know how far they want to go. Maybe they want to go above 100 inches if they want to. You never know. So we will have it as a normal text input style. And then for parameter icon, we can use this one to look like distance, how far you want it to go. And then if you hit finish, a new window will pop up like this with the exact program that you just had in this little box right here. This is how you connect. Where each parameter plugs into. So we have the speed. We can just drag and drop that into our speed or into our move block right here, just like that. So if we want to go slower, we can just change that right in here, and it will automatically route it into our program right here. And then for the distance, we can plug that into here where we did the math for the rotations. So distance in inches will go into here, and it will divide by the circumference of your wheel, and then it will do exactly what we said earlier. So now, whenever you have a new program, you go down to the bottom and you see My Blocks. If you click on that, there is your My Block. It's right there. And if I drag and drop that right into here, I can select what speed I want it to go. If I want it to go whatever speed, just like we talked about earlier. Say I want to set it to 50. If I type it in 50, and then I want to go 10 inches straight, it will do exactly what we just did all the way over here, but simplify it into one single block. And this will allow you to very quickly integrate this entire program into your overall program. And instead of having to type out every single step every single time, you can just do this. And you can see how the more complex your processes become, the more time this will save. And this is just an incredible time saver. Very, very, very useful. And yeah, so this is basically a very, very basic intro into My Blocks. And if you double click on the My Block, it will open up the actual program inside of it. So even if you need to troubleshoot something, then if you double click, it will put you right into the program just like that. So yep, that's basically it for today. We learned my blocks, and we learned how to make a gyro straight program. Very cool, very, very useful here, especially in competition where you need accuracy, where you need precision. This is a lifesaver. And you can automate, you can do a lot more things just like this. You could do gyro turns. You can use the gyro sensor to calculate your turns. So if you want to go 10 degrees to the right or 10 degrees to the left, you can also do that using this logic here, even though you'll have to change a few values and a few blocks. But you can do that too. And this basically, the possibilities are limitless. You can use this for anything. Make really, really long processes into one single block. It's seriously a lifesaver. And yeah, that's basically it. Thank you for watching, and I'll see you guys next time.